Okay, guys, I think it's time for us to start. Can you hear me? If you can hear me, just type 1 or 2. Okay, thank you. Okay, we start, huh?
Yes, you
As
can
you
start,
get
bro.
in, our topic. Okay, so Mr. Thank you. As you get in, our topic for today is the Sundray Smart Switch Network Design. That's mean how we can design network with a Sundray switch and the the technologies that have or the protocol is support in our switch. Okay, first part tips. If any question, you can input in this chat group, in this chat box. My colleague Link will give you a reply. And also, if you feel that the voice is not clear, you can use the client of this Zoom. And also, after the training, we will have an exam. So if a question, you can open your microphone and ask me direct. And after you ask, you turn off your microphone. Okay, just remember that you will take the exam after our training, and at the end of this series training, we'll give award to the top 3 attendees. They have the top 3 scores. Okay, for the content, we have 3 parts. First part is a network design principle and the technologies we can choose for the network design. And the second part is the some network scenario. In a different scenario, we may consider different technology. And the last part is a configuration, that how we can configure it with our smart switch. Okay, let's see the first part, network design, principle, and technology options. The main technology we'll talk about is Link Aggregation, MLAG, stacking, and VRRP. Okay, we start from topology. From this topology is for educational campus network. It's like lots of universities, high schools, they will have a similar network. We just have a little analysis for this network. This network is not that high reliability because you are saying it in the this new campus, it only had one core switch, and the core switch only have one leaks to each distribution switch. The distribution switch, you can see the distribution switch in here is only one leak. It's only one leak. So if this leak is down, actually this whole building will lose their connection for the network. And the good things for this one, you can see have the 3 leaks. They have the redundant leaks for the internet connection. They have the 3 internet providers, and in the gateway, they are using a load balancer. So this part is a good design. But for this, we need to know the core switch, they may be broken, the whole network will go down. And also, they have this single point failure risk in this leak. It is also the same problem we can find in the old school, area, the former area. So you can see that between the old school and the new school, they have one fiber private line. Yeah, that's have the connection for these 2 schools, and also they have a VPN connection. So this also provide a redundancy. So you can see after we analyze this network, if we want to get a high reliable network design, we need to follow this principle, this network design principle. This network design principle is like devices redundancy. Devices redundancy means we need to consider the redundancy on the device level, right? The device level is like if this core switch is down, what will happen? If these controllers is down, do we have a backup controller, right? If this switch, distribution switch, broken, do we have a backup switch? Is that the hot standby or the cool standby? For standby, or is like a geo redundancy? The geo redundancy means that we have the backup devices in the different locations. Maybe one is in the Philippines, another one is Asia, right? First, we need to consider about the technology we used to achieve the device redundancy. And the second one is the leak redundancy. The leak redundancy is easy to understand. We need to consider if one cable is broken, and if we have the backup, how we can get the backup. Not the technology we can use like leak aggregation, right? We have the two cable that logically one, and also the technology like the MLAG. We have the leak aggregation across two switch, and also the backup leak and the smart leak, and also like dynamic OSPF and the policy-based routings, and also we connected to the multiple ISPs. These methods or technologies we can use to achieve leak redundancy. And then is load requirements. For this load requirement, we need to consider about the concurrent users, the traffic in our network. If we have the redundant thing capability for the utilization of this network. For example, we have a core switch. This core switch in ARP table is like 1K, right? 1,000 ARP capabilities. We can have the 1,000 ARP entrance in these tables. So we need to know that for this network, if the users number more than 1,000, definitely it will have some problem. So when we consider that, when we do the network design, we need to think about the capability of our devices. Okay, for that three principle and the protocols we can use it like load balancing, leak aggregation, MLAG, and OSPF, MSTPs, the Spanish trees. And also for the network failure or to detect is detect is network failure. We can use it like layer 2 or layer 3 for detection technologies. This one can use like the timers, also like preemptions. For this one, it's like we have the two leaks. If we have the two devices. If the one is broken, we will keep do the hello message. If it's more than like the 5 minutes, more than 5 seconds, it doesn't have any reply. We can see there the another peer is down. We can become the active one. And when the former devices, if we configure with higher priority, when it's come back, because we already enable this preemption, so they will take this master rule back. And also for we are forced to prevent the loops, we can use the STB. It is the Spanish tree protocols, STB, RSTB, PVSTB, and the MSTBs. So from this topology, can you try to find that what is advantage and what is the disadvantage of this topology in terms of the high availability? Here is a test. So this test, you can see that the questions, which answer you want to choose. Let me check. You can see first one, the core switch are not redundant. There is a risk of single point failure. The B, there is a single point of failure at the load balancer. B, after the fiber leak between the former campus and the new campus is 14. There are virtual VPN line that can be backup. So this is a good redundancy design. And also the leak of redundant leaks between the information center building and the core switch. So what is answers? The correct answer for this one is the A, B, D. They don't have the redundancy on the core switch. Also, they don't have the net single point failure on the load balancer, and also lack the redundancy between the distribution switch and the core switch. Okay, now let's choose that to have a high redundancy network. What technology we can choose? The technology we can choose is the Link Aggregation, MLAG, Stanky, and the VRRP. So here we will analyze this technology one by one. Let's see this Link Aggregation and MLAG. For the Link Aggregation, it will achieve the redundancy and load sharing. And also same with the MLAG. The difference is the Link Aggregation, it also just have the have the redundancy on one devices. Is one device to another device, right? Between these two devices, we have the two connections. But MLAG is like we have the two devices, we do the Link Aggregation. And the Link Aggregation is between two devices and going to another one. Actually, you can see that it's two devices Link aggregated to a third device. And for the requirement for the Link Aggregation is support the manual Link Aggregation and also support ACB. For the MLAG, it supports static manual. And for the Link Aggregation, we need that two devices have the similar software attributions. And also for the MLAG, we also need the same hardware, same software attributes. And also we need for the member port, we need to configure the same speed, duplex, and the VLANs. Now let's see the Stanky and the MLAG, the compare with two technologies. For stacking, we know that it's a virtualization technology in the operation system level, right? If we have the two switch, after we do the stacking, the operating system will enter a special stacking mode. The two switch will have only one control platform. We log in the switch one, maybe the part of this virtual stacking units, and the switch two is another device, is another part of this switch. So the two switch, we can say this almost become one. So this is the deeper level of the virtualization. And for the Stanky, we can support up to 8 devices. For this, Stanky also have its disadvantage. It's like when we do the updates, it takes a longer time for the interruption of our service. Because two switches, they're become one. When we do the updates, usually what we did is we update, update one, and another one will also be effective. And for the reliability, so you can see that because that two devices is hyper like virtualizer in the higher level, so it's can affect to each other, so it's have a lower reliability. But for the MLAG, when we look back at MLAG is just a layer 2 virtualizations. When we do the when we enable the MLAG, two devices actually still have their OR control system. When we configure the switch, we configure it one by one. It still have their OR IP address. The only thing is like these two switch can do the Link Aggregation across to each others. So it's like a Link logical integration across devices only. So for this one, we have a higher reliability. That means if this switch is broken, another one will not be effective. But MLAG is like when it comes to the configuration, MLAG is a little bit complex than the stacking, also the management. Now let's see another technology, stacking and VRRP. After we do the stacking, all the member devices work as one in terms of the management, data forwarding, and control. But when we enable the VRRP, it is only have a virtual IP address. That's, you can see it's only a virtualization in the layer 3. That two devices have one virtual IP address and another virtual MAC address. That's all. Two devices still have their own like the control platform. If we use the WebGUI, we can log in their WebGUI, or we can use the console to connect to log in this switch separately or manage and do the configuration. So here you can see that is the difference between the stacking and the VRRP. For the VRP, the difference between VRP and HSRP is VRP is a standard protocol that's be used by lots of vendors, but HSRP, that is a Cisco private protocols. So if you use the Cisco devices, you can use the HSRP. But if you use other brand devices, you only can use the VRP. Also, they have a difference between the two technologies. You can see the VRP is based on the TCP and uses the MAC address, multiple case address, 220.0.0.20, 80, and HSRP is used another multiple case address, that's 224.0.0.2. And also the difference, like for the VRRP, the virtual IP address can be the real IP address of one device. But for HSRP, the virtual IP address cannot be the real device's IP address. So also they have different term for the device standards. For the VRP, one's master, one's backup. For the HSRP, one's active, another one is standby. So that is the difference between the VRP and HSRP. For the Sundray, we only support the VRRP. So no matter is when it comes to the switching, controllers, is only support the VRRP. So when we do the network design, actually we prefer to use the VRP. Even you use a Cisco, right? Because in the future, if you use a Cisco switches and then you use another vendor's switches, you can use a VRP to retrieve the redundancy. Okay, after this technology and the principle analysis, let's go to the second part, the network scenario. For this network scenario, we have, I think we have 5. First one is this one. In this one, we call it the small size. You can see for this network, all the devices, all the switches, they are using the Sundray. And in the core part, we can use the MLAG. We use MLAG and the VRP to have the redundancy gateway for this network. When we say the small size, it's like the concurrent users is we see 500. It's like enterprise. We call it the small size. So in this small size, we can put all the gateway in this core switch. For example, this is a network for this layer, for this aggregation smart switch. All we use the layer 2. Even the switch support the layer 3. We don't need to use these features because all the gateway is a core switch. In the core switch, we just have the 2 core switch. Other switches can just be the like unmanageable switch because our network is not big. So the only thing we need to do is have the redundancy of the core switch. Others, just like you, even we can use a unmanageable switch. Okay, so for this small size, we have the redundancy of the core switch. That is the most important things. And we only need to make sure this core switch has a higher ability. For example, our we have the 500 users. Make sure that our ARP tables is like more than 1,000, and then we have redundancy thing, and we can do the aggregation to other switches. we only need to make sure that the core switch is capable to manage all the network is okay, because we other switches actually is not that important. Just provide the connection. For the small size, the most important is the core switch. Others just like the pipe. Another one is the medium size network. For the medium size network, we need to consider like we will not put all the gateway into our core switch, because our network is already big, already like a big, so we are not allowed. When we do the network design, better don't put all the gateway into the core switch, right? Because we have so many users. If we put the gateway the core switch, we need to say that all the traffic, all the devices other than the gateway is in the same VLAN, right? In the same VLAN. It will be hard for to control the broadcast domain. So we need to make this gateway down to the distribution switch, to the aggregation switch, right? And also for this, we can use the two controller as a redundancy. So you can say when the network size is small, we put all the gateway in the core switch, no problem. But when this network goes a little bit big, we needed to put the core switch. We need to put the gateway into the aggregation switch, and then from the aggregation switch to the core switch, we can configure static routing, because this network is not that big, right? So we just configure the static routing is enough. But when this network become large, super large, it's like we have the big enterprise network. So we have the lot of the distribution switch or aggregation switch. We have many aggregation switch. Then what should we do? We definitely all the gateway is in the distribution switch, right? In the distribution switch, and between the distribution switch and the core switch, it will be hard for us to configure the. But it will be hard for us to configure the static routings, because so many static routings, we will get confused. So in this situation, we recommend to use the dynamic routing. Dynamic routing is OSP. The better use the OSP because OSPF. For this OSPF, the one thing we know is say that all Sundray switch, is that switch is started from RS, smart switch. It supports layer 3 functions. It supports OSPF, support the RIP, and also like other like DHCP servers. These all layer 3 features available to our smart switch. So for the large side network, we recommend to use the OSPF for the routing management. The OSPF, our devices, it support almost all the features of this OSPF. So if we have a larger network, we can just use it. This is another scenario just for the access area. Actually, lots of the project right now, we can use this scenario because the client, they already have their core switch, they already have their network. When they buy our Wi-Fi, right? We recommend they also use our smart switch. So after they use our smart switch, if they have the project, okay, for this kind of scenario, this happens to lots of our protocol. They use our APs. If they also have the CCTV project, they use our switches, especially the PVD switch. And also for some laptops, they can use our access switches. And then these switches be managed by our controller and also the APs. This is the fifth scenario for our smart switch for the data centers. For the data centers, one of the good combination is with the HCI. Lots of the servers. If you also the partner of the Soundforce, actually I think you already done the HCI projects. For this HCI project, you really need a connection between their servers. The connection may be for the storage area, maybe for the management, or sometimes for the surveys. So for this scenario, Sundray can provide is switch. The switch we can use it like 10 gigabits or the 10 gigabit per switch, because for the data center we need high throughput switches for the data for data transition. And let's see the third part, the configuration. How we do the configuration with Sundray switch regarding this the technologies we chose. For the Link Aggregation, you go to the switch management center. In the switch management center, choose the switch that already online and click the Ethernet management. Go to the Link Aggregation. In Link Aggregation, you choose the new and you add one policy. In this one, you can choose the which switch, and then the ports of the switch. You can do the Link Aggregation up to 8 ports per group. After you choose the ports, you choose the property for its VLANs or its trucks. When we do the Link Aggregation, we need to know these precautions. First one, for Link Aggregation mode, it have the manual static aggregation and the LACP mode. So what the difference between these two? For the manual Link Aggregation, that's me. If we have two devices, these are one devices, so I configure the Link Aggregation for 2 port. Another devices, I did the Link Aggregation with the other 2 port. When we connect to this 2 port, yeah, it will do this aggregation without any negotiation. But for the LACP mode, they will have a negotiation. If the one device is not configured with the aggregation, actually another end will not do this binding, not do this aggregation. So we needed to combine this our scenario, right? If that one end they have the chest that will lose the connection, lose that link aggregation. So better we use the LACP, so we can do the detection, we can do the aggregation. If we say that to add, definitely we already configure the aggregation, so we can just use the menu. Because for the menu, no need to do any aggregation. That's the faster way to have this aggregated ports. And also the load sharing. For the load sharing, we can based on the MAC address. We can based on the the source MAC address, destination MAC address, source IP address, MAC address, destination IP address. So you can, according to your network scenario, to use the different load sharing methods. For the aggregation, sometimes it will be failed with our smart switch. If we choose the 2 ports, and it have alert that tell you that 2 ports cannot do the aggregation, you need to check if that ports already enable the features like HTTP Snopy, DHCP Snopy, loop detection, or other features like VRRP, OSPF. If you already configured this kind of the policies to that port, you cannot do the aggregation at that time. So you need to remove these policies out of the port and then do the configuration again. Let's consider MLAG. For the MLAG, is also in the switch management center. You go to the high availability, choose the switch cluster. When you click the switch cluster, you have two choices. One is the one is the stacking, another one is the VRRP. If you choose the VRRP, you will see this page, and in here you need to choose the two switch. Which two switch you will do the MLAG, and then with the MLAG you need to choose is the ports. This is the peer link. After this peer link, you click the save and add MLAG ports. Then you will choose that this port is like one port from the switch 1, another port is from the switch 2. After you configure this, that's done. The MLAG configuration is already finished. You have the two devices that can do the Link Aggregation. Here's the precautions for us to use the MLAG technologies. First one is the peer link. We need to make sure that peer link is a layer 2 connections. We recommend that also can be the truck. And for the keep alive ports, this one is optional. It must be the layer 3 interface. This one is the keep alive port is used to check if there has the multiple masters. If that like peer link is broken, and they will, if the peer keep alive ports still connected, we can check that which one will be shut down. So it can help us to detect, to avoid that multiple master devices. Another one is the close the ports. For this one, we have this one is the part of the MLAG's features. This means you have the two devices, right? For the backup, if one, for example, if the if one device is if the connection between the connection of the peer link is lost, right? The peer link is lost, and then right now some ports some port should be closed. If we don't close the port, there might be have a loop. There might be have a loop. You see that their peer link is loose, right? And then the Link Aggregation, the MLAG technology not works, and then we will have a loop in our network. So during this scenario, some port will need to be closed. So for this one, when you configure MLAG, you need to check that part. That when when peer link is disconnected, some ports, the port on the backup devices will block, will turn off. Now let's see the configuration of the VRRP. For the VRRP, it's also in the high availability. In the high availability, you choose the VRRP policy. In the VRRP policy, you enter the VRRP group. Yeah, in the VRRP group, and you can choose the switches. When you choose the switches, you configure their different priority, their track interface for the preemptions, for the decrease the priority after the tracked ports is going down. So we can have give the different priority, and then the backup switch can be the master. Also, we can enable the preemptions on the mode. So for the precautions of the VRP technology, first one is priority. For the priority settings, we recommend that master devices priority is higher than the standby devices priority, and the master priority after failure is higher than the standby devices priority after failure. Then some scenario, we will use the multiple VRRP group, right? For example, we have the two core switch. This core switch have the 5 VLANs. We have a 5 VLANs for the two core switch. And for VLAN 1, we can be the first switch, be the master. For the VLAN 2, we can let the switch 2 be the master switch. And for the VLAN 3, we let the master 1 be the we let the switch 1 be the master. So you can see we have lots of scenarios to have the multiple VRRP group. So Sundray switch, we also support the multiple VRRP group. And then is the management group and the C group. This one is the I give example you will understand. For the management groups of the VRP is like for the switch 1 and the switch 2, we have the multiple VRP group, right? We need to negotiate to each other. But actually, this is the two devices. These two devices, they talk for the VLAN 1, VRP group in the VLAN 1, and also they talk to the VRP group for the VLAN 2. And also, you can see that we have a lot of the duplicating work while you do the talkings, do the management. So we just get one. We just use the one group as the management group, and then do this kind of the synchronized check if the peer is alive, and also the some priorities. So we let one or two groups to do this kind of things is enough. And for the C group is the member group. If the member group lost all the initiative and the standards, they will synchronize these standards from that C groups. Now let's see the configuration of the stankies. For stankies is also in the switch clusters. In the switch clusters, you choose the two switch. After you choose the two switches, you choose the stanky ports, and then configure the hello message timeout, and configure the then after you do this one, you need to save the connection, save the configuration, and then after that, actually the switch will have automatically reboot. After reboot, they will become alive. Our controller will detect it again. After it be detected, actually it will be work as like a new switch. For this new switch, you need to approve it, because the two switch become one new switch. So you need to approve this new switch and make it online, and then configure the network, like the IP address, give the IP address to this one. Also, you can configure the multiple master detections. So this is the configuration for the stand case. So for the stand case, we need to ensure that we need to configure the stanky port. For the stanky port, right now, only the fiber port supports the stanky. That's mean if you have a Sundray switch that it doesn't have a fiber port, like me SFP port, it cannot do the stanking. And also, if we use the port to do the stanking, we need to know that the port must be the highest speed that port support. For example, this port is a 10 gigabit SFP plus port. So you need this port to do the link aggregation. You need to use the 10 gigabit fiber module. If you have a switch, it's the 10 gigabit port, but you use a 1 gigabit SFP, actually cannot do the stacking. So when you do the stacking, the port only support is the largest speed. And for the versions, if we do the stankies, make sure that the versions with the switch is the same. And also the same with the controllers if we use in the same mode, fit mode. Because for the switches, if it go online, it will not synchronize the versions from the controllers. So make sure that its firmware that control of the switch is also same with the controllers. And also the last part, the prevent loop by applying the stanky cables. When we do the configuration of the stankies, we need to make that switch online first. After the stanky is configured, and when the stanky restart automatically, you need to unlock the network cable of the one switch and manually to manually prevent the loops. After the stanky switch is online, you can connect it back. Because usually when we do the when we do the stanky, we use the two cables for the stanky ports. We use the two ports. We use the two connections between the switch for the stankies. So if we configure the stanking, the switches will go offline. And during this time, you can unplug one switch, one cable, and then we use the one cable that to switch online. After that, we can connect it back. Okay, so this is all the content for today's network design and a smart network design.